For as long as we have looked up at the night sky, one small, reddish point of light has captured our imagination. This is Mars. It is more than just a planet, it is a destination. It represents a future where humanity is not confined to one world. The dream of going to Mars is about exploration. It is about our deep need to see what is over the next hill, or in this case, the next orbit. We are a species of explorers. Our ancestors crossed oceans and continents. Now we look to the stars. Mars is the next logical step in this grand human adventure. It calls to us a silent invitation across the vastness of space. The idea of traveling to Mars inspires us to think bigger. It pushes us to solve problems that seem impossible today. This quest drives innovation in science and technology. It encourages young people to study engineering, physics, and biology. The dream is not just about planting a flag on another world. It is about securing the future of our species. Having humans on 2 planets would be the ultimate insurance policy against any catastrophe that could harm life on Earth. This makes the journey to Mars not just an exciting goal, but perhaps a necessary one for our long-term survival. The pull of the red planet is a pull towards a more resilient and hopeful future for all. Mars is a world of incredible wonder, waiting to be explored by human eyes. Imagine standing on its surface, looking up at a sky that is a pale pink color. You would see 2 small moons, Phobos and Deimos, moving across the sky. You would see Olympus Mons, a volcano 3 times taller than Mount Everest. You would see Valles Marineris, a canyon system so vast it would stretch across the entire United States. These are not just features on a map, they are real places. Places where future astronauts could walk, conduct experiments, and unravel the planet's ancient secrets. The sheer scale and beauty of Mars make it an irresistible target for human curiosity. Why do we feel this powerful connection to Mars? Perhaps it is because of all the planets in our solar system, Mars is the most like Earth. It has a day that is only about 40 minutes longer than ours. It has polar ice caps that grow and shrink with the seasons. Evidence from our robotic explorers suggests that billions of years ago, Mars was a warmer and wetter world. It may have had rivers, lakes, and even a shallow ocean. This raises a profound question. Did life ever exist on Mars? Finding the answer to this question is one of the most powerful drivers behind our desire to go there. It connects to our own origins and our place in the cosmos. Our journey to Mars began long before we started planning for human missions. It started with our robotic ambassadors. For decades, we have sent orbiters, landers, and rovers to scout the red planet for us. These missions were our eyes and ears. They sent back breathtaking pictures and a wealth of data. The Viking landers in the 1970s were the first to successfully touch down and send back images from the surface. They performed early experiments to search for signs of life. While they did not find definitive proof, they laid the foundation for every mission that followed. These early pioneers showed us that reaching Mars was possible, even if it was incredibly difficult. The next generation of missions brought a new level of exploration. Rovers like Sojourner, Spirit, and Opportunity became our remote-controlled geologists. They rolled across the Martian terrain for years, far longer than their original missions were planned for. They found clear evidence that liquid water once flowed on Mars. They discovered minerals that only form in the presence of water. This completely changed our understanding of Martian history. It transformed Mars from a dry, dusty world into a place that might have once been habitable. These little rovers were true heroes of exploration, teaching us valuable lessons about how to operate machines on a distant planet. More recently, sophisticated rovers like Curiosity and Perseverance have taken our exploration to a new level. They are like mobile science laboratories. Curiosity has been analyzing the chemistry of rocks and soil inside Gale Crater. It confirmed that ancient Mars had the right chemical ingredients to support life as we know it. The Perseverance rover landed in Jezero Crater, the site of an ancient river delta. Its main job is to search for signs of past microbial life. It is also collecting rock samples that a future mission will bring back to Earth. This will be the first time we study pieces of another planet in our labs here at home. Beyond the rovers, orbiters like the Mars Reconnaissance Orbiter have been mapping the planet in incredible detail. They have helped us understand the climate and geology of Mars. They have identified potential landing sites for future human missions. They even act as communication relays for the rovers on the surface. We have also sent a small helicopter, Ingenuity, which proved that we can fly powered aircraft in the thin Martian atmosphere. Each of these robotic missions has been a crucial step. They have given us the knowledge and experience we need to confidently plan for the day when we send not just robots but human beings to the Red Planet. Getting humans to Mars is a monumental task. It requires a new generation of technology and careful planning. Organizations like NASA and private companies like SpaceX are working hard to build this bridge across space. NASA is developing its powerful Space Launch System, or SLS rocket, and the Orion spacecraft. These are designed for deep space missions. The plan is to first return humans to the Moon through the Artemis program. This is not just a detour. The Moon will serve as a vital testing ground. Astronauts will practice living and working in a deep space environment, but much closer to home. This will prepare us for the much longer and more dangerous journey to Mars. SpaceX, led by Elon Musk, has an ambitious vision for Mars. They are developing a fully reusable spacecraft called Starship. The goal of Starship is to make space travel much more affordable and frequent. The plan is to build a large fleet of these ships. They would first refuel in Earth's orbit before starting the long trip to Mars. SpaceX's approach is to build a self-sustaining city on Mars. This requires the ability to transport many people and tons of cargo. Starship is central to this vision. Their rapid testing and development show a serious commitment to making humanity a multiplanetary species. The competition and collaboration between NASA and SpaceX are speeding up our progress. The preparation for a Mars mission involves much more than just building rockets. Scientists are studying how the human body reacts to long-duration spaceflight. On the International Space Station, astronauts are living in microgravity for months at a time. This helps us understand the effects on muscles, bones, and the mind. We are developing better life support systems to recycle air and water. We are also working on ways to grow food in space. This will be critical for a mission that could last for 2 to 3 years. Every experiment on the ISS brings us one step closer to being ready for Mars. International cooperation will also be essential. The journey to Mars is too big and too expensive for any single nation or company to do alone. The European Space Agency, Roscosmos, and other space agencies around the world are contributing their expertise. They are developing robotic missions, scientific instruments, and technologies that will be needed. For example, the ESA is working on the rover for the ExoMars mission, designed to drill beneath the Martian surface. By working together, we can share the costs, the risks, and ultimately, the rewards of this incredible journey. This global effort reflects the idea that exploring Mars is a project for all of humanity. The journey to Mars is not a simple trip. It is one of the greatest challenges we have ever faced. The sheer distance is the first major hurdle. Mars is, on average, about 140 million miles away from Earth. A one-way trip with our current technology would take about 6 to 9 months. During this long voyage, astronauts will be confined to a small spacecraft. They will be exposed to dangerous space radiation, which can increase the risk of cancer and other health problems. We need to develop better shielding for our spacecraft and new ways to protect the crew. The isolation and confinement will also be a major psychological challenge. Once astronauts arrive, Mars itself presents a hostile environment. The atmosphere is very thin, about 100 times thinner than Earth's. It is mostly carbon dioxide and not breathable. The surface temperature can drop to extremely cold levels, especially at night. The lack of a strong magnetic field means the surface is constantly bombarded with cosmic radiation. Astronauts will need advanced spacesuits and habitats to protect them. They will need to be able to generate their own power, likely using solar panels, and find ways to use local resources like extracting water from ice found under the surface. Surviving on Mars will require incredible ingenuity and resilience. The timeline for the first human mission to Mars is ambitious but becoming clearer. NASA is aiming for human missions to Mars sometime in the 2030s. The Artemis program to the Moon is a key part of this timeline. What we learn on the Moon in the late 2020s will directly inform the Mars mission architecture. SpaceX has an even more aggressive timeline, hoping to send its first cargo missions with Starship in the next few years, followed by crewed missions. Whether these dates are met depends on successful testing, funding, and solving the many technical challenges that remain. But the goal is set, and the world is working towards it. Why does this difficult journey matter so much? Reaching Mars will be a defining moment for humanity. It will be like the first time our ancestors walked out of Africa, or the first time we sailed across the oceans. It will prove that we can overcome immense challenges when we work together. The science we conduct there could be revolutionary. we might find evidence of past or even present life, which would change our perspective on our place in the universe forever. The technology we develop for Mars will have benefits here on Earth. Ultimately, becoming a multiplanetary species is about ensuring our future. It is a message of hope, a declaration that our journey of discovery is just beginning.